My name's Paul Breed. I'm with Unreasonable Rocket. I'm an entrepreneur who's been building and testing things for a long time. I've built multiple engineering organizations and done entrepreneurial development in fields in everything from Formula One boats to consumer products to full military qualified products. I'm here today to tell you how we're going to get to space in an inexpensive manner. Snapshot. The concept is to provide nanosat launch. I mean, a third of the people who presented before me need nanosat launch as part of their business. They need it in a scheduled, predictable way. There are over 250 nanosats waiting for a ride. Industry projects 100 a year. The present nanosat launch scheme is very similar to hitchhiking. I'm going to show you a plan that's cash flow positive at the end of 2 years. I'm not a slideware company. My slides aren't great. I have real hardware to show. I've been building real hardware for a long time, and we'll go from there. All nanosats today launches secondary payloads. That's a hitchhiker, meaning the primary payload sets the schedule, sets the orbit, and sets all the other parameters. How many people came to the conference today hitchhiking? Don't see any hands. It's free. Why didn't you hitchhike? It's because there are risks and costs other than the cost of the ride. You can't pick your orbit. You can't look dangerous, much less be dangerous. So we had a guy talking about secondary propulsion. I don't think getting the primary payload to accept your secondary propulsion is going to be quite as easy as he made it seem. You can't control the schedule. If your primary payload is delayed for a year, you have to hold your team together for a year while the primary payload dithers around. That will cost more than what I'm going to charge for a full launch. I mean, you can't do iterative development. You can't fly constellations if you can't control the schedule. So why now? Nanosats started out as an educational curiosity. There are now businesses that have launched multiple satellites for revenue-paying customers accomplishing real missions. They don't like 2-year launch uncertainty and schedule weirdness. They want certainty. There are new manufacturing technologies such as 3D printing, automated winding that lets a small team build things that would have taken hundreds of people in the past. We wish to leverage that. The first round of private commercial enterprises are happening now. We've got SpaceX, Planetary Resources, Virgin Galactic. I like to say NASA is IBM. SpaceX made a really nice DEC VAX, and I want to be the Apple II. And if you see the vehicles across the bottom, the rightmost picture is them sitting in my garage. Both of those have flown. The technical approach. A very, very simple 3U CubeSat launcher, pressure-fed. Automated construction of wound tanks and structures. It's industry standard method of developing wound tanks. I can go over that later. 3D printed motors. This 3D printed stainless motor has got over 20 minutes of firing time. I think it's the first ever regeneratively cooled biprop 3D printed motor fired in the history of the world. Automated mission control. This was the mission control box with the automated checklist that we flew our LLC vehicle with. I can drop it on the ground and kick it, and it's pretty much bulletproof, but it goes through all the pages of the checklist automatically. It says you're ready, you're not ready. The concept is to launch from a fishing boat. You put the thing in a sealed culvert pipe at the factory, you drop it in the water, you back away, it floats upright like a spar buoy, you launch it. Quarterly scheduled launch, 400K if you go on our launch campaign, meaning if there are 5 people ready to go, we'll launch 5 people on that and charge them 400K. If you want a schedule of your own, it's 600K. We've built and flown prototype versions of most of the pieces necessary. Here are some of our wound tanks. We've dealt with the FAA with regulation. The global market is a many billion-dollar market. I could stand up here and ask for a $100 million check to address that directly, and you'd laugh at me correctly. This plan achieves that end goal by addressing the first profitable plateau, the sort of smallest plateau that can be done and achieve cash flow positive. Initial plateau is 10 million a year or 25 launches. We've got some competition. Here's a curve of actual CubeSat launches following a nice exponential. The business fundamentals, 400 and 600K price points, 125K vehicle cost, 50% gross margin, cash flow positive at the end of year 2, do cash flow funded growth to become a large company. The exit plan is to build a viable business. We're showing revenues in the $10 million range at the end of 4 years, cash flow positive at the end of year 2, and we're looking for about $1.5 million that gets us to cash flow positive. 1/3 capital, 1/3 operating expenses, 1/3 salary. As founder, I will take no salary until the company is cash flow positive and will continue to contribute $150K a year during development. And we're ready for questions. Can you hand that to them? There, is that better? There, now I've got the mic on. So yeah, I just handed some hardware you can pass around and look, so go ahead.
So one of the questions I had, one of the key aspects, it seems, of your technology is the 3D printing technology here for metals. But at what size can you actually scale this? Because, I mean, this is a nice model demonstrator, but you're going to need a lot
That's
bigger
actually the size that the 3rd stage motor would be for a 3U launcher. It would have a larger expansion cone, but that's actually about 80 pounds thrust, which is about right for a dedicated 3U launcher.
But how big will this scale?
Presently, the present technology can go into about a 10-inch cube, which gets you about an order of magnitude, so another 30 kilograms instead of, or 60 kilograms instead of 6. The technology is evolving.
Okay.
First stage probably would have a more traditional construction.
Yeah, by the time you had to cut off and freeze your business plan write-up, I think since then Virgin Galactic announced a new dedicated...
Yeah, I had a pitch in my business plan about why Virgin Galactic wouldn't be in there. I can address that with the slides on competition. One of the problems with Virgin Galactic and X-Core is they're going to be really secondary payloads because they're manned vehicles. So they're going to have restrictions on safety and things like that that are going to be very similar to the secondary payload restrictions. Right now, Virgin Galactic is planning to stage out of New Mexico. No one has ever gotten an FAA launch license for interior launch. So if they're going to do launch, they're going to have to set up a base someplace on a coast. They're also in the $10 million launch price, not the $500 to $600K launch price.
Could you summarize for us the test program you've already had and what still needs to be done in terms of what your rocket has achieved and where it needs to go?
So we have a bunch of pieces of, we have flown guided liquid propellant vehicles for the Lunar Lander Challenge. The primary complexities that we don't have from that are we need to get the mass fractions, which is largely dependent on tanks, and we've partnered with Microcosm to develop very lightweight tanks. We have tanks in hand that have the mass fraction necessary to do this. This is one of our structural test items. We haven't done staging and we haven't done supersonic aerodynamics, which are pieces that we haven't done. We're working on the supersonic aerodynamics with friends of ours at a company called Flowmetrics and also flying some experimental aerodynamic guided stuff, supersonic. Motors, our group has fired things from 75 pounds to 35,000 pounds. We've fired a 35,000 pound hybrid motor. I don't personally like hybrids, but I had a customer for that and did that. And so it's mostly stand up a business and take all the pieces we've been developing for 4 years and turn it into a launcher business. Yeah. I've basically been doing this myself and, self-funding in the several hundred K a year range, developing bits and pieces. And the question becomes, is it now the time to turn it into a real startup?
And so to date, how high is one of your rocket launches flown?
Well, that's an interesting question. My guided vehicle has been to 1,000 feet. My unguided supersonic test vehicles have been to 18,000 feet. That's not very high, but the performance is really about mass fraction. And for the Lunar Lander Challenge, we had the vehicles with the lightest mass fraction and the lightest weight comparatively. And we have to do the development there.
One other question for you. So what aspect does reusability of your vehicle play on the economics of your flight? And what are you doing for recovery, particularly since you're going to be recovering from...
When I grew up, TVs were repairable. Now you can throw them out. That was accomplished by making the manufacturing really cheap. I have no recoverability plans at all. The goal is to set up a mostly automated facility to just crank these out at low cost and throw them away. Reusability would be cool. It's really hard.